Okay, so here is your Chapter 7 toolkit, and I added some practice problems at the end as well because normally we would do warm-ups in class and I would do one of these problems every day of the chapter. So since we don't get that practice, I decided to add them to the end of this toolkit. So it's super important that you do look through this on your own first. See if there's anything that you can answer. Some of the stuff we might not have completely covered yet. But I do think I've introduced at least everything once, and some of it was last semester as well. So hopefully this is a really good review, and you can use this on your Chapter 7 and 8 tests. So Chapter 7 and 8 this semester will be merged into one test, just like Chapter 5 and 6 were, just because we have to cover less content in a shorter amount of time. So, okay, so let's get started. So you have learned about conditional probability. Calculating probability when some information about the event is already known. So we're given some type of information, given a condition, you can say. So we're given some condition that's true, and we want to calculate the probability of finding something really specific within that condition being true. So here we have a table of 2 dice, okay? So say if I were to roll 2 dice, let me find my little dice simulator here. So if I were to roll 2 dice here, the sum of those 2 dice, 3 plus 6, is 9. That would be the sum. So I roll 2 dice here. 2 plus 1 is 3. 3 is my sum. Do it one more time for good measure. 5 plus 3 is 8. So 8 is my sum. So what we're doing on this toolkit is we're writing the sum inside of the table. So I want you to go ahead and fill in the rest of this table, pause the video, fill in the table with the sums. So 1 plus 1 is 2, so 3. I'm going to fill it in rather quickly just so that those of you who listened and paused and did it on your own first won't have to wait too long. But make sure you know how I'm getting these numbers. I just know the pattern, so it's faster. Please excuse my sloppy handwriting. Okay, so those are all the sums. We completed the table. Calculate the conditional probability of rolling a hard 6. That is the probability of rolling 6 with 2 3s. So just like we did in our first lesson of Chapter 7, that one was about rolling a hard 8, or 8 the hard way is also what they said. So that means that it was a 4 and a 4. 4 plus 4 is 8. There is only one instance where we could do that because there's only one 4 on each of the 6-sided die. So the exact same thing applies here. So let's go ahead and see. We know that whoever this is rolled a sum of a 6. Okay, we know that for a fact. So what is the probability of rolling just a 6? I'm curious. Well, what I recommend we do is we go through and highlight all of the sums that are equal to 6. So if I look through here, I see right here I have 6, the 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, and 1 plus 5. So it looks like there we have 5 6s out of how many total sums here? And I'm going to apologize right now for yawning, clearing my throat, or saying the wrong word because it's super late. So please be patient. I do apologize. So the total number of sums here, if you see, it's a 6 by 6 square. 6 times 6 is 36. So 5 out of the 36 sums in that table are a sum of 6. So to calculate the probability of a hard 6, you're going to look at the sums of 6 only and determine how many of those are a hard 6, or in other words, 2 3s. It looks like there's only one, right? Right here. Only that one is 3 plus 3. 3 and 3. So that is the only possibility. So in this case, it's one hard 6 out of how many number of ways are there to roll a sum of a 6? Well, we counted that there were 5. right? There's 5 orange shaded boxes there. So our probability to roll a hard 6 or rolling 2 threes is 1/5. You can rewrite this as 0.2 or as 20%. You want to make sure you know how to convert from a fraction to decimal to percent and from a percent to decimal to fraction. Okay, you want to make sure you're familiar with that. That is a prerequisite skill that you should know. So make sure if you're struggling, you either reach out to me or you YouTube how to do it. I'm sure there's plenty of videos online. All right, so this is just a little blurb on top of the conditional probability. What we used here was the multiplication rule. It wasn't in its formal state, but that's essentially what it was. Okay, so this is very important for you to pay attention to. The key word to know when to use this, when something is conditional probability, is when you see the word given. And I'm going to highlight that in red here. So if you see the word given, that means you are using this formula, the multiplication rule. So here I see what is the probability of 2 4s given a sum of 8. So we know that whoever was rolling the 2 dice rolled an 8. It could be a 2 and a 6, 3 and 5, 4 and 4, 5 and 3, or 6 and 2. Okay, so what we want to do here is see, okay, well, the probability of A and B, so this would be A and this would be B. The probability of 2 4s and a sum of 8. Okay, so let's look at all of our sums of 8. So it looks like I have 1, 2, 3, 4, 5. Okay, so sum of 8, I have 5 sums of 8. How many of those are a hard 4? 4 plus 4 would be right here in the middle. Okay, so 2 4s, that's our A. So A and B, here I have 2 4s and a sum of 8, obviously, right? 4 plus 4 is 8. So that is what goes on top, 1. There is one pair of 4s that add up to 8. Okay, and then out of the total number of the sums of 8, we have 5 of them. So once again, this one is a 1/5 possibility. There's others too. 2 and 2 would give you 4. 5 and 5 would give you 10, and 6 and 6 would give you 12. Okay, so again, this is 0.2 or 20%. That is the probability of rolling 2 4s given, it's a sum of 8. Now, if it was like 2 4s, just the probability of 2 4s in general, then it would be 1 out of 36. Because if we're not given what they got as their sum, we don't know for sure it was a sum of 8. If I just say, what's the probability of 2 4s? Your answer would be 1 out of 36, not 1/5. So I was not specific. I did not tell you that it was specifically one of those 5 sums of 8. All right, so here's an example where we can apply the multiplication rule. Okay, so in Canada, 82% of the households have televisions, 65% of households have TV and internet access. What is the probability that a house has internet given that it has a TV? Now that given is super, super important. Okay, that means this is conditional probability. We are only looking at the people or at the households who have a TV. That's it. Nobody else. Or like not people without a TV. Okay, those we're not paying attention to. We're only paying attention to the people who have a TV to see how many of them have internet access. Okay, so here, let's see what we got here. We are told, I'm going to color code here. We are told that 82% of the households have televisions. 65% of households have TV and internet. So that and there is going to be my A and B. Okay? So since it says, what is the probability that a house has internet given it has a TV? So whenever we see this, that a house has internet, this is your probability of A, and has a TV would be the probability of B, because in the formula it's A given B. So then that just helps you set up your actual formula. So what we're trying to calculate here is what is the probability of internet given we know they have a TV. Okay, I'm gonna zoom in just a little bit because I know I'm gonna run out of room here. So write pretty small. So this one would be the probability of having both internet and a TV over the probability of just having a TV. We're only looking at the people who have a TV. Okay, there we go. All right, so it tells us the probability of internet and TV in that blue section there I highlighted. It says 65% of households have TV and internet access. So that's the blue portion. 82% of households have televisions. So this is just the probability of having a television. So we can just set this up as 65 over 82. We need to divide that, okay? So if I do 65 divided by 82, 0.792. You can even put 0.7927, but I just go to the thousandths place because then whenever I convert it to a percentage, I still have a decimal there. So this is about equal to 0.792, which is about equal to, oh wait a minute, would I round up that 2? I would. The 6 there after the 2 would round up the 2. So I need to go back. This would be 793, which is about equal to 79.3%. So 79.3% of people who have a TV also have internet. Okay, especially now, I'm sure the majority of people who have a TV, because they're all smart TVs, I bet you anything that percentage would be even way higher because you need internet to use a smart TV, right? So I bet you anything the number of people who have TV and internet is going to be super high. All right. So this is just a quick little definition, nothing much to it, but if you ever see the term mutually exclusive, that means that two things cannot happen at the same time. So I really like this example. It's saying being naturally blonde and having naturally black hair are mutually exclusive because you cannot, I mean, maybe a super rare case, but in reality, like in general, you cannot be born a blonde and born with black hair. You just can't, right? It's one or the other, okay? So just that type of example. It's like also like if you're 13 years old, you cannot be 11 years old. Those two things are mutually exclusive. There's no way they can happen at the same time. So that's all that definition means. You won't be tested on it, but it's good to be familiar with it. All right, so the addition rule. I do believe we did some of the addition rule back in fall semester, but if not, here it is. So here's how we use this. This one, the keyword is not given, the keyword is or between two events. Okay, so here it says a recent survey of high school students said that 74% of students were in a math class, 48% of students were in a science class, and 35% of students were taking both math and science. So here's the question. What is the probability a randomly selected student was taking math or science? Okay, so let's go and start color coding a little bit. I'll make all my A's blue. So since it says student was taking math or science class, because it's A or B, so math is going to be my A and science will be the B. Okay, so it says here 74% of students were in a math class, 48% of students were in a science class, and 35% of students were taking both math and science. So that's this here, the probability of A and B. That's what that is, okay? Let's see if my blue, there we go. The yellow kind of took them away. All right, so here's how we want to set it up. So this is the probability of math or science. I always shorten the terms as much as I can. So science is green, math is blue. So if it's the probability of A, that's the probability of math, right? Plus the probability of B is the probability of science. Okay, with me so far. Make sure you pause if you're lost so that you can catch up a little bit. And then it's minus the probability of both. You can either write math and science, or you can just write both. It's totally up to you. So math, science, both of them. And the problem gives us all of these components here. So the probability of math was 74% because 74% of students were in a math class. So we're going to write 74%. And then the science, it says 48% of students were taking a science class. So plus 48%, I'm just following my rule here. And then minus, I'll go and use orange for the both here, minus the 35% of students who were taking both of those classes, because we don't want to double count it. So we're just wondering, like, what's the probability we grab a student who's either taking math or science? So if I listed out all my students who were taking math, and I listed out all my students who were taking science, and I listed all my students who are taking both math and science, the students who are in both math and science will be duplicated. Okay, so their names will be duplicated on that list. And I don't want that to happen because then that would skew my data and I would get the wrong probability. So we have to subtract out those students who are taking both math and science so that we can just see, okay, what's the probability of math or science, right? So we have to always, we cannot just add math and science together. If I were to do that, I would get, so 74 plus 48 would be 152, I believe. Wait, no, Champlin. 122. I'm doing it in my head right now. Yeah, that should be right. 122. Okay, so there's no way that we can have 122% of people, right? The max is 100% of people, of a group of people. So that's why we have to subtract out both. So here, so if that one is 122 minus 35, we have 7, 8. So we have an 87% chance to pick a student who's either in a math class or in a science class. Let me just double check my math here real quick. Yeah, okay, cool. All right, so make sure that you pause the video. If you ever need more examples of this, it's called the addition rule, okay? Feel free to look it up whenever you need help with it. All right, so here, parallelogram, this one's important. So the opposite sides are always parallel. Okay, the opposite sides are also congruent as well. The consecutive angles are supplementary, so they add up to 180 degrees all the way around. So they equal 180 degrees. Okay, it says diagonals bisect each other, so that means that if I have a diagonal here to here, and whoops, sorry about that, and here to here, okay, that means that those two diagonals are going to bisect each other, which means they are going to cut each other directly in half. So this side equals this side, and this side equals this side. Okay? Opposite angles are also congruent. So you can kind of see already how I marked this with one and this with one, because those two angles are equal, and this angle equals this angle. So just, there's a lot of things here about a parallelogram. So we're going to use them to solve for these problems here on the right. So the first problem says, what is the length of segment OJ? So our goal here is to find this length. First, we have to solve for x. So if I look at diagonals here, so like here and here, what do we know about each side of that diagonal? Well, since the diagonals bisect each other, each half is equal. So we know that x plus 40 equals 2x plus 18. So now if I solve for x, get 40 equals x plus 18. Well, that's going to be, oh no, that'll be fine. All right, so this will be x equals 22. So it didn't ask me what x equals, but I needed that to find OJ. Okay, so if I have 2x plus 18, instead of the x there, I'm going to put a 22, because that is what I just solved for x. I got 22. So this will be 44 plus 18 equals 62. Okay, so it's not degrees or anything, but the length OJ is 62 units. Okay, so now here I see we're dealing with, ooh, this one's tricky. Here we are dealing with angles. Here's what we know. We know this angle is equal to this angle, and this angle is equal to this angle, and also the angles are supplementary if they're side by side. So in order to solve for this, we first need to find one of the variables, and the only angles where there's the same variable are D and C, and we know that those two add up to 180 degrees. So let's set up a little equation over here. I'm going to go ahead and zoom in. So we have z minus 15 plus 2z equals 180 degrees. So those two add together because they are supplementary. Okay. So here first I'm going to combine like terms. Z plus 2z is 3z minus the 15 still equals 180. So we're going to add 15 to both sides. We get 3z equals 195. My brain, I think it's 63, but I want to make sure. 195 divided by 3? Yeah, 65. Okay, so divide both sides by 3. We're going to get z equals 65. Okay, so if we know z equals 65, then we can now find the rest. So z equals 65, then this one is 65 minus 15, which is 50. So this angle here is 50 degrees, so is this angle here. And since they're supplementary, this one must be 130 degrees, or you could have done 2 times 65 here, because z is 65, you're going to get 130 degrees. So knowing that like these pairs are supplementary will really help you with these problems. Because if they add up to 180, that's an easy fix if you're able to set up an equation. Okay, so there's that one. Complete the square review. This is important. You guys want to keep on practicing this skill. Okay, so first I'm going to draw a line. And my first step is to move, add, or subtract the c term from both sides. So here I have to add the c term back over. Okay, so this is going to be, oh, no, I don't. This one was already done. Done already. Done. But what I would rewrite is x squared plus 6x blank equals negative 2, because we do want the c on the right-hand side. Sorry about that. All right, so now it says add b over 2 squared to both sides of the equation. Okay, so here what we have, b is the term that's attached to the coefficient of x. So 6 is our b. So this will be 6 over 2 squared that we're going to add to both sides to complete the square. That is the same as 3 squared, which is 9. So I'm going to go ahead and add 9 to both sides here to set it up as a perfect square. I'm going to have x squared plus 6x plus 9 equals 7. Okay, so that was basically the step, the rewrite and simplify I did right there. So now we have to complete the square into the form x plus b over 2 squared. So here's how we do that. Sorry, you guys know I like color coding. Okay, so to write that, we're going to have parentheses squared equals 7 still. Okay, and our x plus our b is 6 still. It's the same b over 2 squared. 6 divided by 2 is 3. And it was a positive 6, so it'll be a positive 3. So inside here will be x plus 3 squared. So now this is in perfect square form. And we now must take the square root of both sides to solve for x. So if we take the square root here and here, do plus or minus. So we have x plus 3 equals plus or minus square root of 7. So here I'm going to go ahead and subtract the 3 from both sides. So we're going to have x equals -3 plus or minus root 7. And honestly, this might be your answer choice on the test. It just all depends on how the test is going to be written for the chapter 7-8. So we'll find that out sooner before the test. All right, so that is how you would solve that. You can always plug it into the calculator to get decimals as well. Okay, quadratic formula. So the a terms, I'm going to make orange. It's always the term that's attached to the x squared, okay? Now the b term is attached to the coefficient x right there. So this one's going to be a -8. And the c term, right there we go. That one's the -24. So do not give up on this. Many mistakes I saw were the algebra with simplifying after you already put it into the quadratic formula. So just go very slow and carefully, okay, if you're struggling. So I'm just going to kind of set up everything in parentheses and then color code my way to plugging things in. So this could always be a template for you as well if you wanted to like set it all up. So our b is -8. So I'm going to put -8 inside of the parentheses. And I always recommend that you are using parentheses, okay? So a is 2. This is an a and that's an a. And then c is -24. Okay, especially right there where you have to multiply like negatives and whatnot. You want to be really careful, okay? So for simplifying, the negative times -8 is just a +8 plus or minus. -8 squared is 64. Now I have -4 times 2 times -24. -4 times 2 times -24, 192. And all over 2 times 2 is 4. Okay? So 64 plus 192 is 156. Let's see if that's a perfect square. So, yeah, so it was 64 plus 192. Oh, it's 256. I'm sorry. I was like, 156. What? 256 is definitely a perfect square. So this is a really nice one. 16 is the square root of 256. So here, you're probably like, wait, where did the 256 come from? I'm totally thinking you had 8 plus or minus the square root. Those two added is 256. So then we have 8 plus or minus 16, because 16 is the square root of 256 all over 4. Let me just make sure. Yep, 16. So now we can split them, okay? So we have x equals 8 plus 16 over 4. X equals 8 minus 16 over 4. So we get x equals 22 over 4. No, I'm sorry. Yikers. 24 over 4. And you guys should have just heard Macy growl at me. Not growl. She does like these upset like groans, like whenever I'm loud and she's trying to sleep. So I hope you guys heard that. She's very cute. Okay, so these would be your answers here. So make sure you solve that. Go step by step. Be super careful. Double check your work. what does it mean to factor a quadratic? So the first way to factor it is to use the Xbox and area model to write the quadratic, not it, the quadratic as a product. So something times something else. And then we can use the zero product property. Zero product property, or solving, it really just means to solving for the x-intercepts. Another way. And you can factor like the basic method or completing the square, quadratic formula. Desmos can help you out, all that good stuff. Alrighty, so here's expected value. So we did go over this, so I'm going to go over it rather quickly. But I see here that this is a 90-degree angle, so add a 360, that is just 1/4. So if this is a straight line, then that means this one's also a right angle, so this would be 1/4. And the 6 is 1/2. We can also write that as 2/4. Okay, now you guys, since these are nice clean decimals, you can totally convert these to decimals like this. They are the same thing, they are equivalent. So now the expected value, here's what we'll do. I'm going to color code a little bit. So the expected value of -3 is 1/4 of the time. That's how often we'll get a -3 if we were to spin this spinner. Plus, let's go ahead and do the 10. We're just going to see like if we come out and break even or come out on top, that type of thing. So we have 10 times 0.25. Oops, I made a mistake here. It's not 0.25 for the half. Hopefully you guys caught it. It's 0.5 for the half. All right, so for this half, you would earn a 6 if you land on it. That's not too bad considering the only negative here is a -3. So it sounds like you guys could definitely come out on top depending on how much it would cost you, you know, in an alternate universe to spin this spinner. So this one would be 6 times 0.5. Okay. So you can honestly put that directly into your calculator if you want, like -3 times 0.25. Just be careful because it does leave more room for error if you type something in wrong, right? So you always want to really, really double check what you're typing in. 10 times 0.25. And then the other one was 6 times 0.5. 0.5 works too. So my expected value is 4.75. All right, there we go. Assume the $3 and $5 sections are split evenly. Okay, so if this one is a 90-degree angle, that's at a 360. So 360 minus 90, what's left is 270. So if we divide that by 2, 270 divided by 2, okay, it's going to be 135. So this one is 135 out of 360, and this one is as well if they're equal. So here's what I like to do. Let's go see what type of decimal it is once we divide 135 by 360. See if we can make it a little bit easier. I do normally have students like jot down all their work, show how they combine fractions, added, multiplied, all that good stuff. 0.375, that's not too bad. So equals 0.375. Okay, and this one is 0.25. All right, so what you'll do is you are going to follow the exact same steps over here with those decimals and these values inside of here. And you should come out with a rate, just a number, okay, as your answer. So this one is on your own. Go ahead and give it a shot. Pause the video and do it right now. All right, let's see here. Yeah. Hopefully these go by fast. Okay, so a soda company conducted a taste test for 3 different kinds of soda that it makes. It surveyed 200 people in each age group about their favorite flavor, and the results are shown in the table below. So I'm going to start going a little bit faster. So first things first, I'm going to get out my calculator on my phone so I don't have to keep going back and forth. So I got to add up the totals first. So for under 20 plus 126, I have 203 students or kids under or people underneath 20. So then here I have 67 plus 75 plus 58, 147. So if you could do this while I'm doing it as well, just because you're going to have to do something like this on a test. You will have to do it on your own. 78 plus 34 is 200. 41 plus 49 is another 200. Okay. And then let's do for soda A, we have 97 plus 88 plus 141, 300. Wow, a lot of people like soda A. I wonder if any of them will beat them. It looks like soda C has quite a few, but I don't think as many as soda A. Okay, so soda B is 44 plus 75 plus 78. And again, I'm doing all this calculation on my phone just so it's faster. Plus 49 is 246. And then we have 126 plus 58 plus 34 plus 10. So it's going to be 228. All right, so now if you go to add those up, it should, okay. Oh, it says 200 people in each age group. Did I add wrong? So up there I had 67 plus 75 plus 58. Oh, whoopsie. I don't know what went wrong there, but I added wrong there, and I must have added wrong here as well. I'm sorry, guys. Double check all my math. Hopefully I catch it before the end of this video, but we'll see. So yeah, so that would be 74. Yeah, so this one would also be 200. My bad. So that means there are 800 total people. So a quick way is we can add up those 3 totals on the bottom and make sure that it does indeed add up to 800. Interesting. So, oh my gosh, I typed in the wrong thing here. Yeah, user error. That's why I like Desmos, because I can actually see what I typed in. I'm like, oh yeah, that was totally wrong. Oh, and then 228. Yep, 800. Okay, cool. So, by the way, this is an 8, not a 3. Okay. So, soda A given 20 over 39. So, how many people like soda A and they're 20 to 39? So, it'd be right here. So it'd be 67 out of the total number of people who are aged 20 to 39. So this is all I really need you guys to set up for this one. You can definitely try out the decimals and percentages to practice, but I really just need the fractions, okay? So the probability of age 40 to 59 given soda C. Okay, so I'm focusing on soda C. That's my given. And age 40 to 59. Okay, so here, age 40 to 59 given soda C. 34 of them like soda C. Okay, or I'm sorry, 34 of them who like soda C are 40 to 59. And then the 228 is everybody who did like soda C. That one was popular. B actually is most popular. I'm kind of surprised about, but all right, soda B given under 20. All right, so let's see here. Soda B given that they're under 20. So I would look at the given that they're under 20, and then here we go. Soda B under 20. So this one would be 44 out of 200, because there are 200 people in under 20. Okay? So now here I have age 60 and over given, so you see, I see all the given words, given no soda A. So everything but soda A. So this senior, 60 and over, okay, does not want soda A. So I'm going to go ahead and start. Let me think here if I can start. So 60 and over, so soda A right here is 141. I'm starting to get super sleepy, guys, so I do apologize if I start not making complete sense. I really hope I do. And then the total number of people who like soda A is 326. Okay. We actually did a problem just like that, if not the same one, on the, I think it was on lesson 7.2.1, or was it up here and I just didn't realize it? Yeah, it's right here. So it's the same. So I want you guys to try that one out on your own. So it's not on 721. An example of this exactly, example is up above. So I'm going to go and pause here and see if I've given you guys enough info to try to do the rest on your own. And I truly think I have. Heck yes, I did. That's exciting for me. So I want you guys to do numbers 2, 3, 4, and 5 on your own. It's super important that you do those, okay? So get those done. You got this. Post them. Email me if